But we have other effective sampling methods we can choose. So what we've already seen so far is this first image called simple random sampling, where we had the whole population and we just randomly chose people out of it to be our sample. There are other codified ways for us to do this, and it may be advantageous for us to use other techniques. I'm going to come back to the other information that's on the front of here, but this right here is a visual diagram to just summarize all the things we're going to learn. We're going to learn about stratified sampling, systematic sampling, and cluster sampling. Okay. I guess I could talk about this now before we go on. We already kind of discussed this today. Convenience sampling, it's where it's obtained easily and not based on randomness. One of the most obvious, probably that we don't even think about, but it's a very popular type of convenience sample, are those in which the individuals and the sample are self-selected, meaning like they choose to participate in the survey. These are also called voluntary response samples. Why do you think that these voluntary response samples are probably not the best we could use? Well, it's definitely not the entire population, like we said.
Not a lot of people would want to do it.
Yeah, if let's imagine things that you might be asked to give a response about. Let's say you go to what's a restaurant y'all like? Cane's. You go to Cane's and you get Deliani as your server, and you're like, that girl did not serve me very well at all.
That is not true, guys. I am an amazing server.
So let's say that you had a terrible experience, and you get asked to leave a survey. Are you going to have a very typical experience at Cane's? No. Or let's say that it's Deliani, so you go ahead and leave her the best tip and the best response ever. Okay, the people who are offering their own opinions usually have very extreme opinions about things and very extreme options. So a lot of times these voluntary response samples give you crazy high or crazy low ratings on things and not a lot of normal ratings. Because if something's only meh, you're probably not going to leave a rating. Like if it's only okay. You're going to leave a rating if it's really, really good or really, really bad. Think about the times you probably wrote a review on Yelp. It's probably when it was real bad. And all the places you go that are fine, you never read a review. Stratified sampling. Stratified sample is obtained by separating the population into non-overlapping groups called strata, and then obtaining a simple random sample, like we did in the other notes, from each stratum. The individuals within each stratum should be homogeneous or similar in some way. Okay, calculator note for you. When performing this type of sampling, you need to set a different seed for each sampling that you do for each stratum so that you get a completely different and real new set of random integers. So let's see what this looks like. We got a nice image showing us the population getting put into strata and then pulling samples from those. The president of DePaul University wants to conduct a survey to determine the community's opinion regarding campus safety. The president divides the DePaul community into 3 groups: residents, non-residents, and staff, so that he can obtain a stratified sample. Suppose there are 6,204 residents, 13,304 non-residents, and 2,401 staff for a total of 2,109 individuals in the population. The president wants to obtain a population size of 100 with the number of individuals selected from each stratum weighted by the population size. So resident students account for what percentage of the sample? Well, they are 6,204 out of the 21,000. So in your calculator, what is 6,204 divided by 21,909?
Big fraction.
Give me it as a decimal, please. 0.28. So percentage-wise, that's 28% of the sample. Non-residents account for 13,303 out of that 21,000, which is what percentage of the population or of the sample? 61. 61% of the population, so it should be 61% of the sample. The staff account for What percentage of the population?
11.
11. So if they're 11% of the population, theoretically they should be 11% of the sample. So if we want a sample size of 100 people in total, that means from each group I'm going to need to pull a certain percentage. So I'm going to multiply 2.28 times 100, which is 28 residents, 0.61 times 100, which is 61 non-residents, and 0.11 times 100, which is 11 staff members. These happen to be nice and neat numbers because we picked 100 people, 100 sample size of 100. I'm leaving the math there so that you can see what you can do later. Sample size of 100 require these. If the sample size is different, you change the number 100. It's not as quick with the math. Okay, so let's see. If we want to pick the sample of resident students, how many, or what seed should we pick? I honestly don't care. 12, great. We're all gonna set our seed at 12 and we're gonna write down in our calculator what numbers we would put, or what we would put in the calculator to get this number. So everybody right now, we put 12 store math over to probability and rand. So it should return to you 12. Then we press math, probability, random integer, no repeats, and then you need to fill out the rest of it. What is the smallest number we would probably use in this sample? 1. What's the largest number we might use in this sample?
28.
We want 28 people. If we were to sit there and number our residents so we know which one we're talking about, how many residents do we have? 6,204, and our sample size is going to be? This one's 28. So your rand int should look like this. Rand int, no repeat. And it should be, once you press enter, 1, 6,204, and then 28.
Oh,
Sample size is 28. Because we have our lower limit and our upper limit of the sample, numbered from 1 to 6,204. If we press enter,
oh, wow.
it should give you a list. The unfortunate thing is it's really hard to see all of the numbers when the sample size is 28. We're not going to write them all down because that's annoying. But compare with your neighbors. Did you get the same sample as they did when you did this in the calculator?
No?
Let's go for non-residents now. What do y'all want to set the seed at?
7.
Great. So everybody in your calculator, you type 7 store rand. And then you can go back. Are you laughing at rand? Oh. You can go back and do the random integer no repeat. This time, what's our lower limit? What's our upper?
13.
And how many are we choosing?
61.
That's our sample size. Very good. As long as you do that in your calculator, check with your neighbor to make sure you have the same list. These lists have 61 numbers in it. So like, whoa. We're setting the seed at 27. We're actually going to write down these numbers. So we're going to press 27, store, math, probability, the first option, set our seed at 27. Then we go to math, probability, option 8. Our lower limit is 1. Our upper limit is what? 2401. And how many are we choosing? 11. When we press enter, it's going to give us a list. If we started to write this down, don't press anything else yet, by the way. If we started to write down these numbers, because they're only 11, we can write down 11 numbers this time. We'd get 313, 263, 204. Are y'all getting the same ones as me? 1607, 1299, and then, oh my gosh, I can't see it anymore. Right? Doesn't it go off screen?
Yeah.
So problem, we need to figure out how to see the entire list. So what you're going to do is you're going to press that store button one more time. And so it's saying that it's going to take your answer and store it, and then you need to put it in the first list. To get the list, you press second, stat. it should pull up a screen that says names. Put it in L1. So press enter and then enter. Now, if you go look at your stat edit menu, stat edit, it has your numbers. It stored it in the list number 1. So now we can see the rest of them, which is 704, 389, 1901, 1045, 350, and 976. So yeah, I'll write down how to get there. You press the store button to get L1. You press second and then stat. Enter. So let's discuss for a little bit. What are some advantages of this type of sampling? Over simple random sampling. What might be something we get to see if we break people into groups like resident, non-resident, and staff before we pull a random group?
You don't get more of one group than the other.
Okay, it will be more representative of your population, correct? Because we are obviously pulling 61 non-resident students, since that makes up 61% of the population. Great, what else? Let's say we get all of this data and we have these opinions about the school. And let's say it's all in an Excel document. Can I sort the Excel document so that I only look at the staff?
Oh, yeah.
And I only look at the residents? And I only look at the non-residents? So what this allows me to do is see if there's characteristics of each stratum that are significantly different. Maybe even the residents and the non-resident students agree about something that the staff doesn't. In this way, with stratified sampling, we're going to be able to see that, which is very important in drawing conclusions later on. Now we have systematic sampling. Systematic samples are obtained by selecting every certain number of every kth individual from the population. The first individual selected corresponds to a random number between 1 and k. No frame is needed for this type of sampling, meaning you do not need to obtain a list of all individuals in the population. So this is a very big advantage here, because we don't have to know every single customer that comes to a store to be able to pull a random sample. We can use systematic sampling to get a better look at what's happening. So the manager of Kroger Food Stores wants to measure the satisfaction of the store's customers. Design a sampling technique that can be used to obtain a sample of 40 customers. All right, so the manager is thinking about it, and he decides to obtain a systematic sample by surveying every 7th customer that comes out of his store. He randomly determines a number between 1 and 7, say 5. He then surveys the 5th customer exiting the store and every 7th customer thereafter until he has a sample of 70 customers. 40 customers. The survey will include customers' numbers, and we need to list them out. What is the first customer he's going to sample? Customer number 5. What is the next customer he's going to sample? 12. How did you get 12? Added 7. What's the next one? 19. And then, cool. We're going to keep adding 7 over and over again, but since this is a process where I need 40 numbers, we're going to do it in a very, very systematic way. Systematic sampling. So on your calculators, I want you to go back to the home screen, and I want you to put 5 plus 7. What do you get?
12.
Amazing. Immediately, just press plus 7, because your calculator is going to say answer plus 7. It then takes your answer, which was 12, and adds 7. What was the next number? And the next number, just press enter again. Don't press anything else other than enter now. 26, enter. 33, enter. 40, enter. 47, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I want you to keep going until we have 4 rows of this many numbers, because that would be 40. But once we have our whole set, this would be the number of customers, or the customer number of each person in our survey. 278 customers coming through Kroger, that's a pretty good like size. But we do have to have some considerations for what we pick as K, which is the number we're skipping in between each customer. K must be small enough to achieve our desired sample size, but also large enough to obtain the sample that is representative of the population. So why in general would picking a K value of 4 or 30 both not provide us with appropriate results? If we were, even in this example, skipping every fourth customer, that would be 5, 9, 13, 17, 21. Aren't we going to get our entire sample of 40 people pretty quick?
Yeah.
Will that be representative of the entire population of customers at Kroger? No, because it's a little too quick. That's what I'm going to call this. It's like it's too quick to fill up your sample size. Doesn't actually get a good much of the population. Why would 30 also be not appropriate? Yeah, let's say you were starting at 5 in every 30. That means the 5th, the 35th, the 65th, the 95th. How long would we be standing outside of Kroger trying to get these customers?
2 days.
2 days. Basically, yeah, this will take too long to get our sample size. We have to start thinking about how quickly, how efficiently we can get these results while maintaining the randomness and the chance. Because otherwise, you're paying somebody buku's amount of money to stand out there and take these samples. You don't want to have to spend your money on that. So here's some steps to create a systematic sampling. If possible, to approximate the population size. We don't have to know the full population, so that's why it's an approximate. Determine the sample size, so how many like surveys you actually want. And then you're going to compute the value K. There is actually a formula for this. You're going to take the population size and you're going to divide it by your sample size. If you get a decimal, which you probably will, you're going to round down, not round up, you're going to round down to the nearest integer. Then randomly select a number between 1 and K and call this number P, the number that you're skipping each time, or we're starting with each time, I guess. The sample consists of the following individuals. Like 5, and then 5 plus 7, and then 5 plus 14, on and on and on until you get the entire sample size that you want. The main idea here is this value for K. Identifying the right K value for systematic sampling is a kind of problem I will ask you about. The last type of sampling we have is called cluster sampling. Sorry. A cluster sample is obtained by selecting all of the individuals within a randomly selected collection or group of individuals. So let's say we take the entire population and we split it like we have in this image. Then we're not taking a random sample out of each stratum, that would be stratified sampled. You're choosing an entire chunk and you're gonna select those and survey everybody, all of them.
Hey, what do you mean? Everyone in that chunk?
In that chunk, in that cluster.
Oh.
Everybody in the cluster answers. So it's like, that would be like saying, because you're sitting at these table groups in my room, if I wanted to survey something about my room, I'm gonna like randomly pick this table and ask all of you guys a question. And that's going to, okay, I'll pick that table. You're welcome. And then ask all of you the same questions, and you are my sample. So let's see how this might work. A sociologist wants to gather data regarding household income within the city of Boston. Obtain a sample using cluster sampling. So let's think. The city of Boston can be set up so that each city block is one of my clusters. Right? Because I think Boston is pretty like east, west, north, south, like blocks, pretty grid. So we can take an entire block and say this is a cluster. Suppose there are 10,493 city blocks in Boston. That's a wild number. I didn't actually check and verify if that's how big it is, but that's huge. The sociologist must number the blocks, probably in some sort of like orderly fashion. And suppose the sociologist has enough time and money to survey 20 clusters, meaning 20 city blocks. The sociologist should obtain a simple, random sample of 20 numbers between 1 and 10,493. Those are my blocks. So I randomly chose an entire cluster and then go to each of those clusters and survey all of the households from the clusters selected. So let's think, in this particular example especially, why is cluster sampling a cost-reducing choice for sampling an entire city of Boston? Exactly, you're getting a lot of them in one area. Imagine actually trying to sample the random population at their homes, and you just did a random sample. You got people over here, and then over there, and over there, and over there. How much gas are you wasting driving from block to block? Or on one block, you ask everyone. You're still randomly selecting the blocks from around the city, so it's still random. But we're asking everybody in the block, so we're getting a lot of information without a lot of travel time, without a lot of gas. You don't technically need an entire frame because you don't know how many people live in each block necessarily. You're just saying this whole block, that whole block, this whole block. So you don't need to know the whole population, which allows us to use this type of sampling for a lot more situations when we don't know the entire population and we can't fit them into strata. We put them in clusters, which is pretty cool, and survey the whole cluster. Now, in real life, a lot of surveys and a lot of studies will have what's called multi-stage sampling. It's exactly what it sounds like. That means we're using a combination of the techniques. So like maybe starting with one thing and then taking those samples and doing something else with them and taking those samples and then putting them into clusters. So we have a multi-stage sampling process. It pretty much is. But sample sizes really need to be considered well because you want to make sure you have enough data to actually draw conclusions, allowing for yourself some predetermined margin of error. And we're going to get into how to pick sample sizes way in Chapter 9, so not for a while, but we do need to keep in mind sample size or how many people are filling out your survey is actually very important for the reliability of your results. So keep that in mind as we go to all the way through these chapters to Chapter 9.